Magandang araw. Ako si Kuya Code. Welcome back to my channel where I teach Python through fun and practical examples. Today we'll be continuing to dive into software design patterns. In this video, we're going to be going over Flyweight. So Flyweight is a structural design pattern that lets you fit more objects into available RAM by sharing common properties between multiple objects instead of keeping all the data uniquely in each object. So in this example, we're going to be making a bunch of bullet classes, and each bullet is going to have a sprite, and then each sprite has a file size. So if you have, hundreds or thousands of bullets on the screen, you don't want to load thousands of images in RAM uniquely for each bullet. That's just a waste. So basically with the flyweight pattern, we're going to kind of like a singleton for the actual image, where we can store a reference to the actual image. So when we make a bunch of bullets, they'll all be sharing the same image instead of having a bunch of copies. So I'll just show you the bullet we're going to use right now. Let me just see where it is on my computer. So this is the actual bullet image. And if I go to properties, well, we can see that currently the bullet is 3,000 bytes. This is PNG, so it's compressed, and normally when you uncompress it, it actually gets bigger. So we're going to be doing some calculations to get the actual size when it's loaded into memory. So that is, but yeah, this is the bullet that we're going to be using for the actual code here. So I'm going to upload or import some stuff first. We're going to make our bullet sprite class. So this is just a bullet sprite class using PIL to actually load and open the image itself. It's not going to, be an actual path that we're saving. We're actually going to be opening the actual image. And now for our bullet class, the bullet class is going to have the sprite itself. It's going to have the XY position on the screen. It's going to have the speed. It's going to have the direction. All of these are just going to be random values because they're not really that important. Just the fact that the bullet, each 100,000 bullets or whatever amount that we're using, is going to have its own unique data, but the sprite is only going to be the one that's shared because the sprite is much bigger than all these values. And now we can just make an actual bullet factory for spawning all the bullets. So bullet factory and sprites. This is our dictionary, which is going to be treated as a singleton for the bullets. Normally, you could just actually have all your sprites here. This would probably be something, more global level, where you can have all your sprites stored this way and not specifically in the bullet factory. But that doesn't really matter for this example. So class method, we'll call it get sprite, CLS, image path, and if the image path is not in cls.sprites, then we can do that. So the key is going to be the image path, but the actual value is going to be the bullet sprite object itself. And then otherwise it's going to return. So basically, if it already exists in there, then we'll just return it, and then if it doesn't exist, we'll add it in, just so we're guaranteed that there's only going to be one bullet sprite that's going to be used for every object. So whenever we're making a bunch of bullets, it's still going to return the reference, which is in the dictionary here. And now we're just going to have one, which I can just copy, called create bullet. This is going to be in our loop when we're making all the bullets. So it's going to create the actual sprite by using get sprite, and then it's going to create the bullet and then just return the bullet. So now in our main method, we are going to get we're going to have 100,000 bullets. This is the actual path of where our image is. And then we can create our sprite. So there is our bullet sprite object. Just to show you the size of it, don't worry about this fancy code. This is just the code for calculating the size. So we have the mode, which is like RGBA, the length, the width and the height of the photo, and then bytes per pixel. Because if depending on what mode it is, each pixel is going to be more or less memory, and then you just multiply each pixel memory by the height and the width, and then we can go ahead and print that out as well. So if I go ahead and put this here, obviously I'm not going to load 100,000 bullets images on my computer because that would be dumb. So I'm just going to calculate the real memory of one of the bullets and then just times that by the number of bullets, just to kind of show if all the bullets were actually going to have their own copy of the image, you'll see how big it would actually be. So if we run this, as you can see, 100,000 bullets is 17 gigabytes or 17,808 megabytes. So this is how much memory it is for 100,000 of the bullet images that we have. And obviously it's a huge waste, which, doesn't actually make any sense. So instead, for the flyweight pattern, what we're going to do is make a list of 100,000 bullets using a list comprehension. So we have our bullet factory. We're going to create bullet, pass in the image path, which is here, pass in the random values for the X and the Y. And then this is basically, it zips them up, and then these X and Y in this zip up is going to be passed into here. So this is just going to give us 100,000 bullet objects, and it's going to randomize all of these other variables. But because we're using the bullet factory, when it calls create bullet 100,000 times, here it's going to just get the sprite, and it's going to just keep on returning the exact same sprite image that we already have. It's not going to continue to remake a whole new image. The image is added to the dictionary one time, and then it's just going to return the reference, and the reference is going to be way smaller than the actual image itself. So this is going to be way smaller, which you'll be able to see. So if we get the sample size of the first bullet like that, and then so that's the actual bullet itself in the list, and then this is the size of the bullet, and then we can just get the estimated totals, which is the bullet size times the length. And now we can just print out some variables or print out some statements to actually get the size of the total size. So as you can see, this one is a 17,808 megabytes. And then in this case, even though we are still taking the bullet size times 100,000, it's only 4.5 megabytes because every single bullet is only a reference to the location in memory where the one image is being saved, rather than having 100,000 images. So if you have a game like bullet hell type games where you have, thousands and thousands of bullets on the screen, it's definitely better to use a flyweight, because this is, realistic, and this is just not realistic at all, because, why would you, that would just crash your computer if you're spawning that many bullets, first of all, by like having to load an image for every single bullet. That would just be a waste. But anyway, that's it for this video. So if you found this video helpful, please like and subscribe. And of course, let me know in the comments if you have any questions or suggestions for future videos. See you next time on Kuya Code. Paalam.